In this lesson we're going to talk about forces and what they do to an object. We'll use arrows and make free body diagrams, and we'll understand that the unit of force, of course, is newtons. So when you push or pull an object, you are exerting or using a force on it. So the forces can change three things. It can change the direction, the shape, and the speed of the object. You can see that he was going fast, now he's going slower. You can see the shape change. This is a golf ball, by the way. They're very hard and very strong, but if you throw it hard enough, you can see that it will deform, which is really hard to see, but this is what happens in slow motion. The symbol we use for force is F. The unit is newtons, named after the scientist. It's a vector, so it has a direction. There are two types. There's a contact force and a field force. The contact force is a touching force. The field force is not touching. So in a contact force, you can be pulling, kicking, screwing, pushing, anything like this. Field force could be electrostatic force, gravity, magnetic. These are examples of field forces. Without touching, but still fields of force. These are some types of forces you should know about. The applied force is the force by you, people, animals, engines, motors, anything that is making the movement. Direction depends on which way they're going, right or left, for example. You also have gravity. It's always towards the Earth's center, always acting downwards in our case. You have the normal. It's always perpendicular to the surface. So if you're standing flat on the floor, if I'm standing on the ground like this, the normal force is always going to point upwards. This will be the normal force. Gravity is, of course, downwards. This is when something is sitting on top of something else. Friction is rubbing. It's between two moving objects and the surface, or the moving object and its surface rubs. So it's always in the opposite direction, slowing it down. It loses energy due to that. Air resistance is the same thing. When you move forward, you're pushing against the air. Air is going in the opposite direction as well. Finally, you have tension in ropes, cables, strings, and it's always away from the place that's moving from. Here are the key words that you should know for the rest of the lesson. So, when you have something, we have a force, we have a whole system of the idea of what's going on. We have a book, I am pushing the book. We have the normal force because of the table, we have gravity pulling down, and we have the hand. So this is called a system. Everything around it is the external world, like the table, the floor, the hand. That's all the external world. And finally, we have an agent, which is the force. Any force is an agent. So pushing force, the normal force, the gravity force. These are called agents. This is how you know the difference between a system, external world, and an agent. Okay, you can see that the book is the system. The table, the earth, the hands, all of these things are all causing a force, so we can call them as agents in this case. Here's a free body diagram that shows everything acting on an object. This is obviously not a free body diagram. This is a full body diagram. Not good. We can replace it with a free body. Instead of drawing everything out and wasting time, you can draw a little dot instead. Everything in the system will be a dot. Now you can add your agents. Anything that is getting applied. I can see that I am pushing this thing, so I will have a force pushing, I will have gravity down, I will have the normal going up, and so on. If there is friction, you will include friction as well in the opposite direction. If there is air resistance, you will include air resistance as well in the opposite direction. So that is my first force, my applied force, my gravity force, my normal, my friction, and maybe even my air resistance. Here's another example. Ball is hanging from the ceiling by a rope. Draw a free body diagram. No problem. Instead of drawing a ball and a rope, I will draw a dot. There are two forces. We have gravity pulling down, and we have tension going up. These are the only two forces. There are no normal because it's not sitting on top of another surface. A book is at rest on a tabletop. Draw a free body diagram showing the book at rest. Again, a dot is fine. We have gravity, and now we have the normal because it's sitting on top of a surface. Easy so far. A force is applied to the left, and then there is a friction, there is air resistance, and you draw a free body diagram. Dot, applied force, friction, and gravity, and normal, all go into this, just like we did in the previous example. Now you have a net force. Imagine you had more than one force in opposite directions. This is going left, this is going right. The total force, what should I do? I must subtract them. 8 minus 5, that will be 3 newtons to the left. This is stronger than this. In this case, 5 plus 4, both are going to the right. They're helping each other. So you add them. The total is 9 to the right. If you have 6 and 6, well, nothing happens. It's balanced. 6 minus 6 is 0. There is no force, no net force. In this case, 4 plus 4 is 8. 8 minus 8, again, nothing will happen. It will become 0. This leads us on to balanced forces. There will be equilibrium. They will be the same as not having any force at all if they're in opposite directions and they're equal. This leads us on to Newton's first law, which we're going to learn about in our next video. An unbalanced force will cause an object to speed up or slow down. Actually, this is Newton's second law. We will leave that there for today. Thank you.